So when you're using synthetic division, you take your divisor and you're trying to find the 0. And the 0 in this case is 9. So synthetic division. Set up the 9 backwards. L. Write your coefficients. 1, -3, -53, and -1. Notice I'm spacing them out so they don't look like that's -53 minus 1. Space underneath your coefficients. Drop a horizontal line. Questions on just the setup. Got to get the setup right. You get the sign wrong, you're doomed. Okay? Drop. So far, so good? Okay. Drop the 1 and multiply and add. Oopsies. I already multiplied in my head. So multiply, add -3 and 9, 6. Multiply, 54, add 1. Multiply and add, and I have a remainder of 8. So we take our original polynomial, say 3rd degree, and we use synthetic division, we use what's called the depressed polynomial. In other words, I take the 3, take 1 away. So this is now 1x squared plus 6x plus 1, and then there's the 8. And this is the confusing part. So let's take a trip back in the Wayback Machine to, somewhere around 4th grade. So if I divide 7 into 22, I get 3 with remainder 1. How do I write my answer?
R1.
Instead of R1, write it as a mixed number. So that's 3 and 1/7. The word "and" though has a very particular arithmetic operation. Anybody know what that might be?
Plus.
It is plus. It's addition. So even though you might not have explicitly been told this when you were in elementary school, every mixed number is really just an addition problem. It's the whole number 3 plus the fraction 1/7. So using that idea, 8 is my remainder. So I add on, 8 over my divisor. My divisor up here was 7. My divisor right here is x minus 9. So it's going to look weird. So my answer is x squared plus 6x plus 1 plus 8 over x minus 9. That is your answer. Okay. Now I'm going to show you how to check it. To check it, we check like any other division problem. We take our divisor, which was x minus 9. We multiply it by our quotient, which is x squared plus 6x plus 1. And then just hold off on the 8 for a second. Okay? So take a moment, do those 6 multiplications, and see what you get with. All right. So you did your due diligence. We checked through. And my problem is I got a minus 9 on the end. And what I really want is a minus 1. So how do I get from minus 9 to minus 1? No multiplying. I add on my remainder. So now that's going to give you minus 1. So that gives me answer. So you do the multiplication just like you did before, and you add on your remainder. Just like you did way back when in 4th grade. What's 3 times 7?
21.
Plus your remainder of 1 is 22. It's still the same process. Now it's just with algebra. Okay? All right. We're going to retry this with box method. We got room here. Okay. So I'm going to make a rectangle. What's my divisor? X minus 9. So I'm going to make column here. 3 rows. X here, minus 9 here. I'm looking for my first part of my divisor, which is x cubed. So this has to be x cubed. What do I multiply x by to get x cubed? X squared. And then x squared times minus 9 is minus 9x squared. And here is your critical juncture whenever you're doing the box method. Whenever you're doing the box method, my next step is I need to obtain my next term in my dividend, which is negative 3x squared. So my next term in my dividend, so how do I get to negative 3 if I am at a negative 9?
Add 6x.
I need to add 6x squared. So x times 6x gives me 6x squared. 6x times minus 9. And you notice those same terms have showed up right here in my synthetic division. Okay, and now I go to my next term, which is negative 53. To get to negative 53 from negative 54, I just need to add 1x. So what do I multiply x by to get 1x? No, 1. Okay, so 1 times negative 9 is negative 9. And now here's the part which didn't do in the box method. We're trying to get back to our last term in our divisor, dividend, excuse me. What do I have to add to negative 9 to get to negative 1? We just kind of talked about it. 8. So what you would do here is just kind of make a third column for your remainder. Okay? So here is my remainder of 8. So x squared plus 6x plus 1 plus my remainder of 8 over x plus 1. So I don't care which way you do it. Got it? When you take your mid-unit test, we're going to do it the same way we did the last one. So we had mid-unit 1. Now we're doing mid-unit 2. So at the end of the week, when you come back from fall break, you're going to get a Cami doc. I'm going to grade the Cami doc. And then you're going to put the stuff on Eliminate. What do I care about? The Cami doc and the work. So when you work through a problem, as long as your steps are correct, say you make an arithmetic error. I'm not going to kill you for it. You lose, I don't know, if it's 5 points, a point. If it's 10 points, maybe 2. If you make multiple arithmetic errors, I'm not going to keep taking off every time you make an arithmetic error. I'm only going to take off if you're doing something wrong. So if you're using the box method and you don't put the proper number here, that's where you lose credit. But if you put the proper number here and just add it wrong, you'll get almost full credit. If you make a mistake in this setup, you're going to lose more credit than if you said, oh, negative 3 plus 9 is negative 12. That's just an arithmetic error. And I'll be able to tell where the arithmetic error is. I'm not going to kill you for arithmetic errors. So if you make a mistake early, but you do the process correctly, I'm only going to ding you for the arithmetic error. Keep that in mind. All right. Next page. So this is the official way to write your answer, quotient plus remainder. So the most common format, using the numbers from above. The arithmetic long division leads to, and I don't remember what you put in there, so you know what I'm asking you to do. Okay. Let's take a look at this one. Okay. Again, I will give you the option. So here's what the first thing you should look for is. If I've got a third degree polynomial, I see 4 terms, I know I don't have any holes. In other words, some of these, we were missing terms. Yesterday we did one with x to the 4th minus 1. So x to the 4th only had 2 terms. I had x to the 4th minus 1. So I know with x to the 4th, I should have 5. How did I come up with 5? I got x to the 4th, x cubed, x squared, x to the 1st, and my constant. So whatever my degree is, I should have 1 more term. If I don't have that many terms, I have to fill in with zeros. In this case, I don't have to fill in anything with zeros. So same process, you're going to do this. If you get this one done, ooh, try the next one. Oh, look. Looks a little different. Okay. So I'll give you a hint. If you get through the second one on your own and you're working on the third one, you cannot use synthetic division. Synthetic division only works for linear terms, and I'll clarify that when we get to it. So this one again, I don't care with method. So long division, synthetic division, or box method. Go for it. Now, but this is where you're making mistakes. The number that you divide by in synthetic is your zeros. So it's not positive 9, because when I might find my 0, okay, Because if you use the positive 9, everything else was wrong. Okay. So now negative 9, 6, 51, negative 24, positive 20. Drop the 6 times, add, times, add, times, add. So my remainder is negative 7. 6x squared minus 3x plus 3. And I'd prefer you write it this way. All your remainders should be plus negative 7 over x plus 9. Don't write your remainder as a minus. I'm not going to mark it wrong, but it's kind of like bad form. Okay? So I'm going to give you a minute to look that over. I'll still come around and answer any questions you got. And then I'm going to set up over here using the box method for the next one. Okay. I would still recommend, however, anytime you have a quadratic and it's got 3 terms in it, my suggestion would be long division. Synthetic division only works when your divisors are linear. So if you see an exponent, synthetic division does not work. I'm not going to get into the details, but only long division and the box method work. So the next one, we'll do it both ways. Take your time. I'm warning you on the next one, the numbers get big. And that's the issue I had when I did it. This one question yesterday, I fell down a rabbit hole. I couldn't find my mistake. I kept trying to do it the box method, that didn't work. So after about 5 minutes of that, I tried long division, and I still having issues. I took a 2-minute break, went and did something. I came back and I found my mistake. Once I figured out what my mistake was with long division, I can figure out how to do it with box method. So take your time with the next one. Before we go to the next one, I will come around and answer any questions you got about this one. I'll give you some more time to work on it. Okay? Exactly. So you need large box. Okay? I'll do this. I'll do the long division on the left, and I'll set up the box on the right, okay? Yeah, again, I'm not going to force you one way or another. Okay? And you know what? I just explained to them why synthetic doesn't work, and I'll explain why it doesn't work on this one either. All right. I'm going to hold the shift key down, so I got vertical lines. So I got a vertical line. Remember in that top left corner, nothing goes there. And I need 3 more rows. Why do I need 3 more rows? Because my divisor has 3 pieces to it. I've got x squared. I've got 2x. And please pay attention. You have a negative 5. Don't just put 5 there. Okay? I'm just going to do the first step. And then from there, you're going to work it. So, my first piece of my divisor, dividend, excuse me, is 6x to the 4th. Okay? So that is from right here. So far, so good? Okay. Next part is I have to figure out what I multiply x squared by to get 6x to the 4th, and that is 6x squared. Then I multiply the 6x squared to my other 2 terms in my divisor. So I'm going to get 12x to the 3rd. And then 6 times negative 5 is negative 30x to the 2nd. The next part is the most critical, and it's the part that you really just have to think about. And this is the difference between the box method and the long division. With long division, I think there's actually less thinking. It's very procedural. Once you get one step, it kind of leads to the other. This one, not so much. This is a little bit more cerebral, takes some logical thinking. The next thing I need to look for is the next term in my divisor, or dividend. And that's 5x cubed. So I have 12x cubed. I want the next piece. I need to figure out what do I add to 12 to get to 5. Well, since 12 is bigger than 5, it has to be negative. So it's really 12 minus what number is 5? And that's 7x to the 3rd. Okay, so I'm going to stop here. You're working on the box method, see if you can do the rest on your own. if you're working on the long division. Okay, so I'm going to, I don't know, 3 or 4 minutes, and then we'll do it both ways. I'm going to do the long division part first, and then redo it with box method. We have enough time. Okay, so erase that little thing. We take our leading term. It's all about leading terms. So here's my leading term, and here's my leading term. I don't care about anything else when I'm trying to find my quotient. 6x to the fourth divided by x squared is 6x squared. And notice I am lining up my like terms. But there isn't a like term. I know, but the 0 is holding that place. So now, 6x squared times x squared plus 2x minus 5. 3 multiplications. So 6x to the fourth plus 12x cubed minus 30x squared. Put the whole thing in parentheses and subtract. And this is where most of you are making your mistakes. You are not distributing the negative sign. So 5 minus 12 is negative 7x cubed. Have I seen that anywhere before?
Right there.
Do you see how the box method mirrors what's going on with long division? Look at it right there. Okay, so now 6x squared did the multiplication. 0 minus a negative 30 is plus 30x squared. And since my divisor has 1, 2, 3 terms, how many terms do I have to have in my dividend to do my next step? So I need to bring down just the 2x. So now, again, just looking at my leading terms only. Negative 7x cubed divided by x squared. So negative 7x cubed. I'm sorry. That's what I'm going to have down here. Negative. Oh, no. I heard it. I killed it. There it is. It's back now. So negative 7x cubed. So I have negative 7x squared times that gives me negative 7x cubed. Negative 7x squared times 2 is a minus 14x squared. Negative 7x squared times 5. Oopsies. That should just be negative 7x. Bye-bye. There you go. Is positive 35x. Whole thing in parentheses. Subtract. And this is where y'all are making mistakes. 3 or 4 of y'all walked around, and this is where your mistake was. Right here in this step. 30 minus a negative 4. At 30 plus 4 is 44x squared. 2 minus 35 is negative 33x. And then my divisor has 3 terms, so my dividend has to have 3 terms. So I bring down my 8. I need to do the whole thing one more time. I'm going to stop here. See if we can mirror what's going on with the box method over here. So I'll give you a couple minutes to do that. Here, let's take a look. Box method. So we've got the 12 and the negative 7, so that's this negative 7x, which we already have right here. Negative 7x times that one is negative 14x squared, and negative 7 times negative 5 is positive 35x. Do you see that that column is the same as this row? They shouldn't be different, right? I'm just dividing different methods, but the process is going to be the same. All right. Now comes the hard part. All about the diagonal. Oopsies. I don't want that one. So I've got negative 30 and negative 14x squared. Negative 30 and negative 14 is negative 44. I don't want negative 44. Wah! What do I want? I want 0. So what do I add to negative 44 to get to 0? 44. So this next term here is 44x squared. Yeah, big. I told you the number's going to get big. So x squared times what number is 44x squared? 44. Do you see how the degrees are getting smaller each time? Second degree, first degree, and then constant. So 44 times 2 is 88. 44 times 5. Oh my gosh, 3-digit numbers. Lions and tigers and bears. Oh my. Nobody?
What?
Lions and tigers and bears? Wizard of Oz. Dorothy says it. All right. So 44 times that is negative 220. My problem, and most of you got here perfectly, is I don't want 88x and 220. What do I want? I want the 2x and the 8. This is why we got 2 pieces to our remainder instead of 1. All right. But the process is still the same. I'm going to have to put a... Get out. We don't have to. Nice. Here we go. Let's go black. All right. So 35 and 88 is 123. But I don't want 123. What do I want? I want 2. Okay? So if I've got 123 and I'm trying to get down to 2, it has to be negative. It's negative 121. So that goes right here. Remember, we're sticking with diagonals. And I don't want negative 220. I want 8. What do I have to add to negative 220 to get to positive 8? 228. So these are your remainders. So it's 6x squared minus 7x plus 144. And here's the funky part. Watch carefully. This is the part that's kind of weird. Negative 121x plus 228 over x squared plus 2x minus 5. All right. So I'm going to take a moment. And this is perfect because I'm going to show you what's behind the curtain. Also Wizard of Oz. Okay? Anybody remember Wizard of Oz or seen it? Okay. So right towards the end, the wizard's not really wizard. He reveals back behind the curtain, which is just a bunch of contraptions where he's pretending the wizard. So I'm revealing it to you now why we can't use synthetic division for quadratics. Okay. So for this particular quadratic, in fact, remember what did I say for synthetic division? It's where it equals 0. Can anybody tell me where that equals 0? No. I mean, we could graph it, and I could show you it actually will never cross 0. We'll get to that a little later. That's part of the reason we don't. Okay. So, because this is actually an equation that you cannot solve with real numbers. Or if I can, real number might be solvable, but maybe I got a square root. Can we divide by square roots? No. Okay. All right. So we got 10 minutes. The next 10 minutes, you should be doing one of the